Hi, madam. I'm Desmond Longhan, the group leader of this project, and my team members Weiqi, Susheng, and Ziyuan are going to present about the project today. Now let me begin with part A of our project, which focus on the implementation process, including its timeline, flow, and budget. So let's begin with an overview with the project implementation. The implementation was carefully structured and broken down into clear phases. A Gantt chart was used to map the timeline, ensuring smooth execution from start to finish. Key tasks included project discussion, which took 8 days, and interim topologies design completed in 14 days. The project budget phase lasted 6 days, while IPv6 address and router configuration took 7 days. DHCP v6 and OSPF v3 configuration required 7 days to ensure proper network communication. Server and internet configurations were carried out in 7 days, followed by SSD's configuration, which also took 7 days. Cloud configuration was completed in 9 days, while testing and debugging lasted 6 days to guarantee system functionality. The final phases, final report writing, and presentation recording were completed in 7 days and 1 day, respectively. This structured approach will allow us to prototype, test, and ensure a reliable outcome. Next, I will discuss the project budget. Firstly, network power, hardware, and components accounted for 300,505 ringgit and 60 cents, which included items like Lenovo Ideas Center AIO PCs costing 174,404 ringgit and 40 cents for 73 units, Cisco 4,000 routers at RM 18,649 and 68 cents for 4 units, and Cisco Catalyst switches at 57,537 ringgit and 55 cents. Additional devices such as servers, access points, and modems contribute to this total. Secondly, software cost total 19,605 ringgit and 93 cents, covering the Kaspersky Premium Plan for network security, priced at 9,125 ringgit, and Negus OP Manager for network monitoring costing 10,480 ringgit and 93 cents. Thirdly, coupling and socket components amounted to 12,629 ringgit and 44 cents, including Ethernet cables, Cisco cables, and network interface modules. Finally, man-hour cost total 46,200 ringgit, covering wages for hardware installation, configuration, and testing at a daily rates of 150 ringgit per worker. This comprehensive budget ensures that we maintain cost efficiency without compromising quality. So the total cost for Part A is 378,940 ringgit and 97 cents, divided into 4 main components. Now let me highlight some of the hardware and software used in this project. The Lenovo Data Center AIO PCs were selected for their sleek design and excellent performance, making them ideal for lab environments. The Cisco 4000 router ISR4331 provides compatibility with both IPv4 and IPv6, supports advanced routing protocols, and includes built-in security features such as firewalls and VPNs. We also use the Cisco C9300L48T4XA, which are high performance stackable switches designed for enterprise networks. For wireless connectivity, the Ubiquiti Enterprise Access Point was chosen for its Wi-Fi 6 technology, offering enhanced speed and efficiency. The Nighthawk multi-gig 2.5 Gbps cable modem is a high-performance modem designed to deliver fast and reliable internet speeds. It supports speeds up to 2.5 gigabits, making it ideal for high bandwidth activities. Besides, designed for chemical and professional use, the Lenovo ThinkPad E14 Generation 5 is a robust and powerful laptop. Its 14 inches display, which offers Full HD or greater quality options, produces vivid and clear images, powered by the newest AMD Ryzen or Intel Core CPUs. It provides good performance for light multimedia use, productivity, and multitasking. In terms of servers, the Dell EMC Power Edge R350 servers are versatile, handling tasks like file serving and web hosting with ease. On the software side, Kaspersky Premium provides robust network security, while Negus OP Manager enables real-time monitoring of the network health and performance. So we also utilize the UTP because it provides reliable and high-speed internet connections, assuring efficient and stable data packet transmission across our network. With the Cisco cable X21, because it is a 3-meter cable specifically designed to connect Cisco devices with X21 data terminal equipment interface to smart serial interfaces. It ensures reliable serial communication, supporting protocols like X21 for efficient network and data transmission. Other than that, we use the Cisco 2-port gigabit Internet 1 network interface module because it is designed for Cisco routers, providing 2 gigabit internet ports for high-speed WAN connectivity, supporting both copper and fiber connections. It offers flexibility for various network configuration, ensuring reliable and efficient data transmission. So in conclusion, Part A of this project outlines a well-organized implementation process supported by a detailed timeline and comprehensive budget. The selected hardware and software were chosen to ensure efficiency, scalability, and reliability. So that's all for me. Thank you.
Afternoon, sir or madam. I'm Weiqi. Today I'll walk through the addressing table section of our network design project. This section is important because it shows how we set up and assign IP address to a device in the network. So first of all, let's see through our network design overview. Our network design includes two main parts: logical topology and physical topology. For logical topology, this shows how data flows between devices, and we created different subnets for specific areas like labs, classroom, and admin spaces. And for physical topology, this is the actual setups of devices like routers, switches, and servers, and PCs based to ensure good performance and easy access. So let's see through our addressing table. First, we have three routers, which is lab router, main router, internal router. Lab router connects two switches for computer labs 1 and 2 and links to the main router. Each connection has a unique IPv6 address, like this. And this is the default gateway. And for main router, this is a central hub that connects to lab router, internal router, and ISP router and server system. From internal router, we manage the connection for classroom, system admin, and admin office. Now for end device like PCs, student PCs, and admin computers, they get their IPv6 addresses automatically from DHCP-v6. So for the server, the DNS server and file server in the server room have fixed IPv6 address. This ensures these key services are always stable. So why is this matter? By having a proper addressing setup avoids problems and makes the network more better. By separating traffic into different subnets, we have made it more secure and easier to manage. Also, IPv6 gives us plenty of room for future growth. So actually, there is one issue we faced was making sure the router could connect correctly and stable, especially when setting up their interfaces. So we fixed this by carefully assigning unique IPv6 address and running ping tests to check everything worked. Another challenge was keeping the network more flexible and secure by using DHCP-v6 protocols. We allowed devices to connect easily while still maintaining good address management. We also tested connection thoroughly, including between labs, classroom, and servers, to make sure everything can run smoothly. So by setting up the addressing table clearly, our network design achieves easier troubleshooting. Problems are simpler to find and fix because addresses are well organized. Better performance. The traffic is split into sections to avoid slowdowns. So, and IPv6 lets us add more devices without running out of addresses. So in the conclusion, the addressing table is a key part of our network. It connects everything together and ensure the network runs smoothly now and in the future. Our careful planning and design make sure it meets today's needs and is ready for what's next. That's all for me. Thank you.
Good morning, everyone. Today, I'll present the configuration process. So basically, our network backbone consists of 4 router, main, internal, lab, and ISP router, each will configure with IPv6 addresses. In the router configuration, the main router serves as a hub connecting to the lab router, internal router, log, and server. It assigns IPv6 address to each interface, such as 2025:2110:0371:4:/64 for server connections. It also enables IPv6 unicast routing to support communications and configuration surroundings to interconnect with the internal and lab router. The internal router connects to the classrooms, administrative office, and tutor PCs. It configured with Unix IPv6 subnet for each segment. The web router supports 2 computer labs and connect to the main router, while the ISP router facilitates internet connectivity. It was configured to connect to the cloud and handle IPv6 traffic efficiently. In next part, to automate IPv6 address assignment, we have implemented DHCP-v6. On the main router, who were configured for the servers and wireless segment. The lab router handles dynamic addressing for device in computer lab 1 and computer lab 2. The internal router ensures dynamic IP assignment for classroom and administrative areas. Each configuration includes the assignment of a DNS server and domain names. Next part is the OSPF33. We use OSPF33 as the dynamic routing protocol to ensure efficient route calculations and network updates. Each router was assigned a unique router ID such as 1.1.1.1 for the main router and 2.2.2 for the internal router. Next part is the frame relay configuration. Frame relay was implemented between the main router and ISP router for efficient cloud connectivity. On both router, frame relay encapsulation was enabled on serial interface. Frame relay rematch was configured with neighbor relationships such as 2025:2110:0371:6:2 for communication between the main and ISP router. Next is the IP access configurations. In the main router, interface gigabyte 0/0/0 and in internal router, interface gigabyte 0/0/1 is invoked to connect to the ISP server. This results that on the computer lab, different classroom and system administrator have internet connectivity, while tutor, admin, other device, no internet access. And thank you for your attention. That's all my part.
Hi, I'm Bu. Now I'm going to show how we configure our server. So this is our project overall. The first server we configured is the cloud server. So we click on the cloud server. And in the cloud server, we have set the DSL. In the DSL, we set a new from the modern port 4 to the Ethernet 6. And for the serial 0, we also set the port status to the on. We add a new main router and set the DLCI is 100. Other than that, we also set the serial 1. We add a new SP router and set the DLCI is 200. The second server we configured is the ISP server. So in the ISP server, we mainly set for the HTTP. In the HTTP, we set to the on, and the HTTPS we also set to the on. In the file manager, we also built some new HTML file. So in the HTML, we have write some text like the multimedia UCD, the FXCT, computer network, and our group member name and the student ID. And in the DNS service, we set to the on. We add a new record, which are the domain name is the IP, com, and the type is for and record, and the detail is the IP address. Next, we also manually set for the IP. We manually set for the IP configuration for the IPv6. We set the IPv6 address, link local address, default gateway, and the DNS server. So the next we set for the DNS server. In the DNS server, we set the HTTP, but in the HTTP, we set the both HTTP and the HTTP to the off. And in the DNS server, we mainly set for the DNS service. And we add three, which is the fcd.com, fcd.com, and MAU, edu, and by. The three type is the same, is the forward record, and the detail is the different IP address. So in the DNS server, we also set the IP configuration. We manually set for the IPv6 configuration, which is the IPv6 address, link local address, default gateway, and the DNS server. Next is the file server. This is the HTTP server. So in the file server, we mainly set for the HTTP. We add a new admin and the password admin, align admin, and the permission is RWDNL. In file server, we also set for the IP configuration server manually. These are the IPv6 address, link local address, default gateway, and the DNS server. Lastly is the web server. In web server, we also set the HTTP. We set the HTTP to the on and the HTTPS also to on. We also set for the IP configuration manually. And like previous two, we set the IPv6 address, link local address, default gateway, and the DNS server. Okay, now I'm going to verify the connectivity in our project. So for the first, I want to ping from the lab 1 infrastructure to the lab 2 infrastructure. So we copy the IP from the lab 2 infrastructure. And then we open the lab 1 infrastructure and open the command prompt. We ping the IP address. So our ping is successful. We can see the packet set is 4, the receive is 4, and the loss is 0. Next, we also can ping from the lab 1 infrastructure into the D class 1. So we copy the IP address for the D class 1. So for the result, the ping also is ping successful. You can see the send is 4, receiver is 4, and the loss is 0. Next, I want to verify the DNS server. So you can choose any PC from the computer lab 1 or in the computer lab 2. For example, I took the lab 2 PC1. And then we copy the IPv6 address from the DNS server. and we ping the IP address. So after a few seconds, the ping is successful. You can see the packet sent is 4, receive is 4, and the loss is 0. Next, we can verify the web server. For example, we choose the left instructor and we open the web browser and we enter the domain name of the web server. So for this project, we set the domain name to the mu.edu.my, and after that, we connect to the domain name, and the connection is successful. You can see the multimedia HTTP, welcome to the MU, and our group member name and the student ID. So lastly, we verify the internet connectivity. So in our project, there are some PC have the internet access, and some PC don't have the internet access. For example, we select the laptop PT, the wireless device 2, and we open the web browser. And we try to connect to the ISP.com. So after a few seconds, the result will show the request startup. This means this PC don't have the internet access. So we can successfully connect to the ISP.com with the PC have the internet access. For example, we open the laptop and we try to connect to the ISP.com. So the result will show the connectivity is successful. It will show like the content in the ISP.com. So that's all from our project presentation. Thank you.